In our second video tutorial, programming tutorial, we want to define objects and classes. And basically, we do something like this. We define a class and we name it box. And this very abstract programming construct will represents whatever our box instances should have regarding data types and also regarding methods. So we define a class box and we give it, because our box should be represented in three-dimensional space, we give it a location vector in space, and we also say it should have some dimensions, x, y, z dimensions. P vector, by the way, is a class provided by Prosing that stores a vector, meaning a tuple, like a tuple of 2 or 3 values, x, y, z, and then you can make some calculations with those vectors and just store the values to start out with, which we do in this example. And our boxes should also have a specific color assigned to them, so we have a third variable called col. In the constructor method of a box, which is called whenever we create a new box, we give it an x value and a y value, both floating point values, and these floating point values inform the locations x and y value. We could of course extend the box constructor with other variables that inform the location more specifically in the z direction or the dimensions, but for our example we already know that the location z component should be set to 0. So that's what I'm doing here. I set the location to x, y, and 0. And I also know that it should always be quadratic cubes with dimensions 20, 20, and 20 in all directions. The color value of our little box should be something red, so the red value of the color command is set to 255. The green value should be set to somewhere between 0 and 255, and the blue should be 0. Now, to start out with, I want to iterate. I want to let the box do whatever it wants to do at some point. So I give it a method with a rather generic name update. And at the beginning, the box should only just draw itself when it updates. It basically updates its visualization or rendering wherever it is, with whatever dimension it has, with whatever color it has. So that's what we do. We will later on call the drawing method box, and now we set the fill value, the filling color value to col, so that the box is drawn its own color. And then we inform the system that whatever rendering commands follow now should not affect any other rendering commands in our simulation. So we call the command push matrix. Then we call the translate command that you've seen in our previous demoing example, and we translate by the location of the box, location y, location z. And of course now we just need to draw in accordance with our dimensions. Dimensions x, dimensions y, dimensions z. And here we tell the system we are done. We are done with whatever drawing commands that we wanted to do. And basically it's very important for the translate command here, because the translate command, and we saw that before, the translate command will change any subsequent rendering command. So basically we say we shift every drawing activity that follows after the translate command by whatever values translate receives as parameter, here location x, y, and z. And then the box that is usually drawn at the origin is translated to that XYZ location. And because we will have many boxes in our system, and these many boxes will be updated or drawn, if we didn't call the push matrix pop matrix commands here, then all the boxes would be translated incrementally and be all over the place. We don't want that. So basically, push matrix, pop matrix ensure that these commands here are executed just for themselves, informing just this one box, and that's it. And that's exactly what we want. Now we go ahead, and in the setup method, we first of all we set up the parameters of our little canvas, and we say processing should switch into 3D mode. That's important. And another thing that we should do is we should create an array list that maintains all our box objects. And in the setup method, we instantiate that boxes container as well. And now what we are going to do is we want to create a grid, a two-dimensional grid of boxes on our screen. So we want to have several rows and several columns. So what I'm going to do here is int row equals 0, and as long as row smaller 20, increase the row index. And I do the same with the columns, and col is already taken, something that we have already used somewhere else. So let me just be explicit about that. Int column 0, as long as column smaller 20, and column should be increased as well. So now we have two indices for columns and rows, and we create a new box B that takes whose X value is determined by obviously column times 25, and its Y value is row times 25 also. And this new box should be added to our boxes container, and that's what we do here. In our draw method, on the other hand, first of all we want to have a nice black background. It's always cool. And we want to iterate through all our boxes. So for int I equals 0, as long as I is smaller than boxes dot size, increase I. And so we iterate through all the elements, through all the boxes there are, and for each index I we retrieve a box object B. And since any kinds of objects could be stored inside a container, even though it's called boxes, we have to tell the system that whatever we retrieve from boxes here with the get method at index I is a box. That's why we write box here in brackets before. So we retrieve the box instance at index I, and we call its update method. Yeah, and if I haven't made any mistakes, then we should see, oh yeah, we do see a little window with 20 by 20 boxes on our screen aligned in a two-dimensional grid in 3D space. Now that's already pretty cool, but we want to go one step further, and we want to let those boxes oscillate. Oscillating box. We create a new class, Oscillating Box, that extends our previous class, meaning we add new functionality or information to this class. In this case, we inherit all the methods all the methods, the update method and the initial constructor of the box class up here, as well as all its variables. But now we add something. We add a target dimensions vector, and we also add a break factor. I need these two new variables to inform the oscillation of the, or scaling, this oscillating scaling, oscillating scaling of the box, exactly. So, oscillating box, the constructor, we have to do the same as before. We have to call a constructor for the oscillating box, and first of all, we just call this the constructor of the box method that we inherit, same as here. And in order to call this constructor, inside of this constructor, we use the keyword super. So we call the box constructor, the original one, and pass it the x and the y that this oscillating box constructor received. And now we have to initialize the target dimensions vector, and that guy is a new vector, new p vector, and we want to set the target dimensions to the original dimensions of our box. And the break factor, because all the oscillating boxes should oscillate with a little variation in their speed, we want to set it to a random value between 20 and 60. Okay, that's our oscillating box, and furthermore we want to override the update method that we have had already previously defined in the box class. More specifically, we want to set the dimensions of our box. We want to set them to target dimensions first, and we do that at every time we call the update method, right? And then we scale those target dimensions by by a value between 0 and 1, and this value is supposed to oscillate. So frame count, no, that's not it, frame count, that's it. Frame count is just a counter provided by processing that is increased at every iteration of the program. And the sine function here returns a value between -1 and 1, but we want to have it just from 0 to 1, so we take the absolute value of whatever the outcome is of that. And we divide here the frame count by the break factor, so that it's not too fast, our oscillation. And then we call the update method of our superclass, which in this case is the box class, so that this code here is executed when this here is called. The only thing that is left to do is change our, so we have a new class name here. So we also want to create those corresponding objects. So instead of boxes, we create oscillating boxes. And instead of iterating through a whole bunch of regular boxes, we iterate through oscillating boxes. We click on play, and our boxes are oscillating with different speeds. Now that was fun. Good.